Hi, we are going to understand a very important algebraic identity called difference of squares. The formula is simple but very powerful. And the formula is a square minus b square is equal to a plus b multiplied by a minus b. By the end of the video, you will know exactly why this works, how to use it, and where it helps in solving problems quickly. Okay, let us first look at the left hand side, a square minus b square. This means you take a number, square it and subtract the square of another number, right? Now let us look at the right hand side of the identity, that is a plus b multiplied by a minus b. This means that we are multiplying the sum and differences of the same two numbers a and b, right? Let us prove that both the sides are actually equal. We'll expand the right hand side using distributive property, right? So here we have a plus b multiplied by a minus b, and this is going to be equal to a multiplied by a minus b plus b multiplied by a minus b, right? A multiplied by a is a square, a multiplied by b is ab, because there is a minus sign, I'll put a minus sign, plus b multiplied by a is ba or ab, then b multiplied by b is b square, then there is a minus sign. Okay, now look at it. Minus ab and plus ab will cancel each other, and what we will have is only a square minus b square, right? And this is exactly what we had on the left hand side, a square minus b square. Okay, let us take an example. Let us say we have a equal to 7 and b equal to 2. So for the left hand side, a square minus b square, a square minus b square, this is a square is 7 square minus b square is 2 square. 7 square is 49 minus 2 square is 4, right? 49 minus 4 is 45. This is what we get in the left hand side. And for the right hand side, we have a plus b multiplied by a minus b. So in the bracket we have 7 plus 2, and in other bracket we have 7 minus 2, right? 7 plus 2 is 9, multiplied by 7 minus 2 is 5. 9 multiplied by 5 is 45, right? You see, in the left hand side we have 45, and on the right hand side also we have 45. So both the sides are equal. Okay, and let us try to find out why this identity is useful and where we can use it, right? So this identity is used everywhere in algebra. Let us look at why it is helpful. The first application is fast calculation, right? You can mentally calculate squares and differences. For example, 102 square minus 98 square, right? This looks challenging, right? But when I break it down, it will look like 102 plus 98 in one bracket and 102 minus 98 in other bracket, right? So 102 plus 98 is 200 multiplied by 102 minus 98 is 4. This is equal to 800, right? So now this is quite simple, isn't it? Second use of this identity is factorization. This means when you see an expression like, say for example, x square minus 9, right? So x square minus 9, we can instantly write it as x plus 3 and x minus 3, right? Because 9 can be presented as 3 square. So this is nothing but x square minus 3 square, that is x plus 3, x minus 3 multiplied together, right? And this is also useful in solving equations, right? So for example, it helps in simplifying and solving polynomial equations faster. Okay, now let us understand a very important note. This identity only works when both the terms are perfect squares and they are separated by a minus sign. It does not work with addition, right? So a square plus b square is not equal to a plus b multiplied by a minus b. You see, it works only when separated by a minus sign. Here we have plus sign, so a square plus b square is not equal to a plus b and a minus b, right? And you need to be very careful with this. Okay, let us wrap it up. We learned a simple yet powerful algebraic identity, that is a square minus b square is equal to a plus b multiplied by a minus b. This is used in factorization, quick mental math and solving equations, right? This formula works only for subtraction of squares. This makes algebra faster and easier, right? So please practice this formula with different examples to learn it perfectly. I will bring more such examples in my next videos. Thank you for watching.